Good afternoon, everyone. In this session, we will discuss about the work and power, the learning objective. So basically, what is work? How we define a work, or definition of a work. It's a basic or a simple concept. An example: you have an object which is lying on the floor, and you apply the force on the object. You push the object, or you pull the object. So you apply the force on the object, and because of the force you applied on the object, what you see or what you observe the object start to move. So when we apply force on the object and the object can move because of our force, we call that as a work done or work. So simply, if we want to calculate the work, so work done is a product of force which we apply and the distance which the object moves. For example, if I apply a force of 3 Newton, an object travel 2 meters. So I applied a force of 3 Newton and object travel 2 meter. So what is the work done? How much work is done? So work done is actually a product of force and distance. So what is the force applied by us? We are applying a force of 3 Newton. And what is the distance moved by the object? That is equals to 2. So 3 multiplied by 2, that is equals to 6. And what will be the unit of the work done? The unit of the force is Newton and the unit of distance is meter. So unit of work done is Newton meter, or it can be known as joule. So we can say a work done is 6 Newton meter or a work done of 6 joule. So unit of work done and unit of energy are same. So simple definition of a work done: a force applied on the object so that the object can move. We call that as a work done. Is it clear? The concept, the basic concept of work done, the force applied to move the object. So example, if there is a wall and you are pushing this wall with a force of 100 Newton, but the wall does not move. So what is the work done? In this example, how much work is done? So that's good, Abdullah. The work done is 0. Why the work done is 0? Because we are applying the force, because the work done is a product of force and distance. We are applying a force, but the object does not move at all. So distance is 0. That's why the work done is 0 joules or 0 Newton meter. You can say joule or you can say Newton meter. And when we are lifting the object, so calculating the work done, it is having two possibilities. Number one, if we are pushing or pulling the object, and number two, if we are lifting the object. So if we want to calculate a work done, if we are pushing the object, say example, there's a 2 kilogram object and we are applying a force of 50 Newton. So when we applied this force of 50 Newton, this object moved from position A to position B, the same 2 kilogram object. It covered a distance of 10 meters. So if I say what is the work done from A to B, So we are applying a force of 50 Newton because the work done is a product of force and distance. So force is 50 and the distance which we move this object, that is 10. So 50 multiplied by 10. So the useful work done is 500 joules, or we can say 500 Newton meter. But when we are lifting the object, so example, an object is there, a 2 kilogram object, and we are lifting this object up to a height of say 5 meters. And the question is calculate a work done. So when you are lifting the object, whenever we are lifting the object up, the force which we apply, that is equals to weight of the object. So if we want to calculate a work done to lift the object from point A to point B, so work done is equals to force. So what about the force? The force is equals to weight of the object. So mass of the object is given 2 kilogram. So mass of object is 2 kilogram. What will be the weight? We know weight is mass multiplied by gravity. So mass is 2 and the gravity on the earth is 10. So weight will be equal to 20 Newton. So basically 20 Newton is the force which we have to apply. That's a minimum force which we have to apply to lift the object. So our force as the weight of the object is 20 Newton. Our force should also be 20 Newton to lift this object, the minimum. So the force is 20 and the distance is 5. So 20 multiplied by 5, that is equals to 100 Joule. So yeah, I can re-explain this. So basically what happened, if you are lifting the object, like if I say there's an object which is on the ground, the mass of the object is 2 kilogram. So what about the weight of the object? Weight is mass multiplied by gravity. So mass is 2 and gravity is 10. So what about the weight of this object? The weight of the object will be 20 Newton. So object weight is 20 Newton, which is acting down. So if I want to lift, if I want to move it up, the gravity is always 10, because this you have to memorize, that the gravity of the earth you will always take as 10, because we are doing the work done on earth. If we are doing a work done on the moon, then the gravity will be 1.6. That's why it is easy to lift the object on the surface of the moon as compared to that on the surface of earth. So the weight of the object is 20 Newton. So how much force, minimum force I have to apply to lift this object? The force which I have to apply, the minimum force should be 20. Practically it will be more than 20, but the minimum force which I need to lift this object, that should be 20. And if I move this object to a distance of 5 meter, so I want to calculate a work done. How to calculate a work done? That is force multiplied by distance. So force is 20 multiplied by distance is 5. So it will be 100 joules. Is it clear? Is it clear to everyone? So whenever you are calculating a work done to lift the object, the force is always equals to the weight. And when we compare the work done, it depends on initial and final positions. Example, we have, this is a ground and this is the first floor. So one person is using an elevator and another person is using the stairs to move from the ground floor to the top floor, the first floor. So the person who's inside the lift, his weight is 600 Newton. The person who's using the stairs, his weight is also 600 Newton. Here, the lift, the elevator is doing a work done, and here we are doing the work done to move from the ground floor to the first floor. So when we compare the work done by lift with the work done by the body, the useful work done, because work done will be there, the different work done, but the useful work done, what is the meaning of useful work done? Means which is used to move from ground floor to the first floor. So when we compare the useful work done by the lift with the useful work done by the body, the human body, the height which both move, travel, that is example, say 20 meters. So as you can see here, when we calculate the work done by the lift, the useful work done by the lift, whenever objects are lifted, when objects are moved up, the work done is equals to, work done is always force into distance, but in that case, the force is equals to weight. So example, weight of the person inside the lift is 600 and the distance which is moved, that is 20. So 600 multiplied by 26 multiplied by 2, that is 12, and then 30, so it will be 12,000. And when we compare the work done by the body, the human body, so 600, because the person, weight of the person is 600 and he is also moving the same distance, so 600 multiplied by 20, so again it will be 12,000 joules. So you can see here, when two objects doing the work done in different way, a lift using a cord and it is moving it up, and we are using the stairs to run the flight of stairs from ground to first floor, but because if the weight of the person is same and it is moving to a same height, then the work done will be same. So work done does not depends on the route or the path followed. It depends on the starting position and ending position. If starting and ending positions are same, then the useful work done will be same. Is it clear, the concept of the useful work done? So in all these cases, the useful work done by the lift is same as useful work done by the body. Body will also produce more energy and in the form of heat. There will be a wasted energy as well. But the useful energy or useful work done by the lift will be same as useful work done by the body, because they are moving to a same height. So if they move to a same height, they follow any route, any path, the work done does not depends on that path. So the useful work done, what is the meaning of useful work done? The work which is done to move the object, that is called a useful work done. Because what happened, as a lift, it is lifting the body up and the body move upward from ground floor to the first floor. But when a person body, like a human body, as it is climbing the stairs, so what happened, the human body also produce heat, so he is losing energy in the form of heat as well. But we are not considering that, we are only considering how much energy is used to move from ground floor to the top floor. So the energy which, the useful energy which is used to move from a ground floor to the top floor will be same as the useful energy or useful work done by the lift. And another person was there, example, there's another person, he is using a ladder. And when we compare the work done, the person is having example a weight of 600 as well, because if the weight changes, the work done will change. So that's why all the examples, the weight is 600 Newton. So here 600 Newton and a person climbs the ladder. So when he climbs the ladder, he's also moving to a same distance. So he will cover the same distance. So work done by the body when climbing the ladder or using the stairs, that will be same. The useful work done. There is unuseful also, like the sum of the energy which is released in the form of heat, that is unuseful, but we are not considering that. We are saying the useful work done, the energy which is used to climb the ladder or use the stair, the run up the flight of stair, or used by the elevator, all will have the same work done. So basically work done, the simple statement, the work done does not depend on the route or the path which we follow. So it depends on the starting position. So work done depends on the starting position and the final position. So simply the work done does not depend on the route or the path which we follow. So if you want to calculate a work done, the work done is force multiplied by distance. The force which we applied multiplied by distance, what we'll get the work done, and the unit can be Newton meter or joules. Next, a crane lifts a load of 1000 Newton through a vertical height of 3 meters. So crane is lifting a load to a vertical height of 3 meters. So we want to calculate a work done. So we have the force which is 1000 and the distance is 3. So 1000 multiplied by 3, that is equals to 3000 joules or 3000 Newton meter. Then what is the concept of power? How we define a power? Power is simply how much work is done in a unit time. So work done in a unit time is refers to power. Like if we include the time interval as well, we refer that as the power. Example, we apply a force of 5 Newton and the object cover 3 meters. So what is the work done here? How much work is done? We are applying a force of 5 Newton and the object moved 3 meters, so 5 multiplied by 3, so work done is 15 joules. But what is the meaning of power? Power means how much work is done in a unit time. So work done divided by time, what we get? We get power. So example, this object work done was 15, but what about time? To move from point A to point B, it took 2 seconds. So how much work is done in a unit time in each second? That's called power. So 15 divided by 2. So 15 divided by 2, that is equals to 7.5. And what is the unit of power? It will be joules per second. So basically every second how much work is done, each second how much work is done, that is known as the power. So work done in a unit time or work done in 1 second, that's simply known as power. So this one is doing 7.5 joules of work in every second, and this joules per second is also known as watts. So we can use capital W. So instead of writing joules per second, we can also write capital W, means watts. The unit of power is watts or joules per second. And power is also having another formula, because work is same as energy, so power is also energy divided by time. So both formulas are valid depending on the question. So how much work is done in a unit time, we call that as power. Then the relation between power and time, like there are two students, moving objects, different objects which are having different frictions, but both are applying the same force of 5 Newton. Student A apply a force of 5 Newton, student B also applies the same force and move this object to a distance of 2 meters. This also moved to a distance of 2 meters. So when we compare the work done, what is the work done by A? So the work done will be equal to 5 multiplied by 2, that is 10 joule. What is the work done by B? So 5 multiplied by 2, that is also 10 joule. So both students are having the same work done. But if I say student A was taking 10 seconds and student B was taking say 4 seconds. So when I compare the power, so power is how much work in a unit time. So work is 10 and the time is also 10. So 10 divided by 10, it is equals to 1 watts. But what about the power for the second student? The work is 10 and the time is 4, so 10 divided by 4, it means 2.5 watts. So what it shows the student who's taking a short time is developing more power. So the relation between power and time, so power and time are inversely proportional. The one which will take So power and time are inversely proportional. The one which will take short time will have more power. So this is a word example. A crane lift a concrete block of weight 12,000 Newton. So we have the force through a vertical height of 8 meters. So we have the distance in 30 seconds. So we need power. How to get power? Power is work divided by time. So what is the work done here? How much work is done? So work is force 12,000 multiplied by 8. That will give us the work done 12 multiplied by 8, which is 96. So this will be 96,000 joule is the work done. So 96,000 divided by the time, which is 30. Which is 3,200 joules per second. So that is the power, or we can also say 3,200 watts. Then what is the meaning of efficiency? Efficiency is a comparison between the useful energy divided by the total energy So when we calculate the efficiency is a comparison between the useful energy with the input energy. Like example, we have a car engine. Example, this is a car engine. So what is the input energy? Which form of energy the car engine, because the car engine is taking a fuel. So car engine is taking a fuel. So which form of energy is there? Yeah, that's good. Chemical. So car engine is taking a fuel. So when car engine is taking a fuel, which form of energy it will have? It will have chemical energy. So the input energy, input means what is taken in. Then what is the purpose of the car engine? We use the engine to drive the car, to move the car. We want the car to move. So which form of energy? The useful one, which we want. That's good, kinetic. So basically kinetic energy is a useful output. But not only car engine is moving the car, but it is also producing other forms of energy which are the wasted energy or unuseful energy. So what is not useful or unuseful energy or wasted energy, I can also say. So the wasted energy, it produces heat and it is also producing sound. So you can hear the sound as well, and it is also producing lot of heat. So what is the meaning of efficiency? Basically, efficiency is a comparison between the useful energy output divided by total input multiplied by 100. So when we compare, so if I say write a formula for efficiency of the car engine, so what will be the formula for efficiency of the car engine? Because the useful output, what is the useful output for us for a car engine? Kinetic is a useful output, so efficiency is denoted by N. It will be equal to kinetic energy divided by the total input. What is the total input? Because it is taking a chemical energy, so divided by chemical energy into 100. So if you want to find the efficiency of the car engine, the useful energy for the car engine is kinetic, and the total energy is which it is taking, that is chemical, into 100. Is it clear, the concept of efficiency? It is a comparison between how much or what proportion of the total energy is converted into useful energy, and it is always in percentage. So you will find like efficiency 30%. So what is the meaning of efficiency 30%? It means 30% of the total energy is the useful one and remaining 70 is the wasted. If I say efficiency is 50%, it means that compared to total energy, 50% is a useful and remaining is a wasted. So we can use the efficiency by useful energy output divided by total energy into 100, or useful power output divided by total power into 100. Now we'll do some questions, so it will improve your understanding. A weightlifter raises 2000 newtons. So we have the force through a vertical distance of 2 meters. We have the distance and time is 0.8. We have to calculate the useful power. So how to calculate the power? Useful power, total power is the same idea. So power is equals to work done divided by time. So first we'll calculate a work done. What is a work done? The force is 2000 and the time, distance is 2. So 2000 multiplied by 2, that's 4000 joules. So work done is 4000 and the time it is taking 0.8 second. So 4000 divided by 0.8, what is the answer? 4000 divided by 0.8. So 5000 watt, so D will be the right answer. Is it clear, this question, this example? Yes, Abdullah Khan, Saim. Is it clear? Okay, another question. A wind turbine generate 54 kilowatt. Kilowatt to watt, how to convert? You will multiply by 1000. So it means the useful power is 54,000 watts. And the total from an input of 180 kilowatt. So that is 180 means 180,000 watts. Which calculation gave the percentage efficiency, or which calculation give the efficiency? So the formula for efficiency is the useful power divided by total power input multiplied by 100. So the useful power, how much is the useful power? It is 54 kilowatt or 54,000 divided by total power, which is 180,000. And this multiplied by 100 is with numerator. So useful power multiplied by numerator 100 divided by total power. So actually this 100 is multiplied by numerator. So when you check, it will be C. So these are some questions related to topic work power, and I'll share another link and continue this discussion.